Today I want to talk about a feature called cladding. Cladding is just a surface that lets you distribute planar, linear, and concentrated loads on bars, panels, and supports. A finite element mesh is not defined in the cladding. It is just an auxiliary object for defining loads. For example, instead of making hand calculations to find areas of influence of structural elements and then applying linear bar loads, just use a cladding. Let's see how we define a cladding. Let's pick geometry, cladding. Pick the load distribution fashion, which will be two-way. This node, this node, this node, this node, that node. And there we have our cladding. Let's apply a load to it, a planar load, which have a -1 kilopascal value, and apply. The loads have been applied. Let's run the calculations. Okay. Now, if you want to check how the load is being distributed to these beams, you may do this. Left click, display loads, load distribution regions. Apply. Okay. You can see by these colors how the loads are being distributed to the structural beams. Now, if you change the load distribution fashion of the cladding to one way, say one way Y, and run the calculations once again, the color scheme will be different because the loads are being transferred in the global X direction, local Y direction of this cladding. You can do this with horizontal claddings and also with vertical ones. Just pick the two-way cladding, pick this node, this node, this node, this node, this node, apply it, close. Now apply a planar load to this cladding and you may check the load distribution by these colors. The beam is picking up the green area and the other columns are picking up the other areas of the cladding. Thank you for watching.